Um, Thanks, Austin. So I'll just do a quick introduction. Who am I? What do I do? Where do I work? And why this topic? Um, Simple question to answer for me. My name is Mahesh Pandit. I work with Deloitte New Zealand, based out of Wellington. Just because I'm based out of Wellington, please don't hold it against me. It's a beautiful place. Coffee is amazing. Double shot coffee anytime. Auckland still needs to catch up on the coffee culture. All right. What do I do? I work a lot in the cloud space. Our cloud security, zero trust, security by design are my areas of interest. That's where I do a lot of my work. Why this topic? It's a bit of an interesting conversation. Why this topic? About 10 months ago, about a year, close to a year, I was talking to a CISO who also happens to be a good friend of mine. And we started talking about some of the cloud transformation, some of the journey that they're going through, what the organization is doing, what he's wanting to do. And one of the questions he says, what is serverless? Why is everybody going serverless? So yeah, it's very interesting. The more and more I started working on the topic, the more and more started working in the cloud space. Realize that's just not his problem. A lot of people don't really understand or haven't actually, correctly to put it, haven't ventured into the land of serverless. And the more you start working in the serverless, it's kind of, you have to change your mindset from how traditional computing is to start working at serverless. So what is exactly serverless? It's a bit of an oxymoron. All right? There is nothing serverless. Serverless, it still has servers in it, still has the traditional infrastructure in it. It's just that you as a consumer, you're not worried about what is serverless. Your job is to let the application run, do its job. Everything else is being taken care of by your cloud service provider. You can see the hardware, compute, network, platform, it's all cloud provider's responsibility. Your responsibility is your data. Your responsibility is managing the encryption to get to the cloud provider. So how did we actually get to serverless? Before I get into the next slide, does anybody know when was the first serverless instance was? When was the first case of serverless? It was in 2008. Google had developed an application which was on serverless concept. Hadn't caught up much, but 2014, with the introduction of Lambda, that kind of was a game changer. People started thinking more in a different language. We started moving towards serverless. So how did we get to serverless? I go back to this Darwin's theory of evolution. We as humans tend to evolve. Just like that, our hosting, the traditional hosting models started to change. We looked at data center. Back in the days, we had massive data centers. Everybody wanted to have a data center. All companies were worried about data center. We looked at saying, that data center is probably not for me. Too much of fixed cost, too many overheads. That's not what we do as a bread and butter. We'll start looking at different models. We started going into colo facilities. We started borrowing racks from people who owns data center. Right? Mr. X, Miss Y, you have your data center. Can we borrow a few rack space? We started hosting our servers in there. We continued that with cloud computing. We started getting out of the colo facilities, started moving towards cloud. And eventually, we just continued, and we are kind of getting into that phase where we are looking at hybrid cloud. So as hardware continued to change, our compute changed. We started looking at physical servers. Back in the days, we had physical servers. Anybody who has worked in the data center racking the servers, I can tell you, whoever said that IT doesn't need physical strength was joking. Absolutely. We moved away from physical servers. Virtualization got better. We started looking at virtual servers. We started moving away from virtual servers, came to the phase of containers, and we started coming slowly towards the next stage, which is actually functions. As our hosting and compute changed, our software architectures changed. We looked at 80s, 90s, early 2000s. We had monolith applications, everything combined into one. Everything was one. We just have a client who is talking to the application, and that's it. We started like, nah, that's not really right. We need to break this. We broke it into multi-tier applications. We had front-end separate, back-end separate. You got your middleware doing its own magic kind of thing. Then we started working on containers, got into the container space. And now we are slowly moving away into serverless environments. It's a very interesting concept. For those younger people in the crowd, sorry, but if you haven't seen a data center, this is how it looks like. If you haven't even seen a physical server, that's how it looks like. That's a photo of a Dell server. And I think more and more we go, don't get me wrong, but the likelihood of any of you walking in the data center and actually hosting a server, the likelihood is going low. So what are the components of serverless? You think about, yeah, this guy's talking lots of serverless. What are the components of serverless? So there are effectively 6 components that we look into. Is the backend database. Now, what does the backend database do in the serverless? It's what your traditional database does. Still using for storing data, managing data, but the role has changed. Your database, scaling of database and scaling of infrastructure is not our responsibility. It's not our problem. When we are making a call to the backend database, how your database is handling, what resources it's utilizing, it's not something that we are worried about. It's all, again, the CSP, the cloud providers looking into that. API gateway. API gateways, we know what API gateways do. They are the basic interaction point. They're the actual engine that is coming and working between back-end and front-end applications or other systems. They're picking up the API call. They do API authentication, authorization. They see what API wants to do and decide where that API is going to go do its job. Security, sorry. Oh. Yeah, sorry. Security service. Security service is all responsible for doing the actually identity access management, your logging, your monitoring. It's all coming from security service. The next step, which is functions. And you also have to think, it's functions, probably I would more correctly put it as more of functions as a service. You have to think. So what do functions do? Functions are executing the application logic. If Mahesh wants to go and do something, depending on what Mahesh is doing, the backend function will do its job. It's waiting for my interaction. It's waiting for my event. Once I click something, there is a backend function which is doing its job. Web server, client interface, they kind of go hand in hand. They work together. They do the front-ending job. They do how your front end or your web interface will work, where your main user interaction is going to be. That's what the front end does. So just going to take you through the some examples that we have here. The classic examples of backend database is DynamoDB, Aurora Serverless. You got here Azure Cosmos DB, API gateways, AWS API gateway, Azure API, Google endpoints, Security Center, Security Hub, AWS Security Hub. You got Azure Security Center as well. Functions are AWS Lambda, Azure Functions, and web servers are usually your cloud CDNs who are doing the front loading of this. So before I get into the next slide, one of the questions, and I kind of covered it in my for the previous one, is what is an event? How do you classify as an event? And why in serverless the event kind of is quite important? Does anybody want to have a go? All right. So an event is typically classified as any action taken by a user or an API or another system. So in a simple way, if I put it, me logging on to a front end can be classified as an event. A user requesting a document and they're picking up that document and getting stored in the storage bucket can be classified as an event. So in a very serverless environment, event allows the environment to be stateless. It allows that environment to scale up and down because depending on what that event is happening, your actual resources are being scaled up and down. And for the security purpose of that, we have to think that event, how do we do it? An event classification. So what are the key security concepts we look at? We look at event data validation. It's very critical in the environment because it's all based on how that event is being driven. We need to validate what that event is. What constitutes an event? Has that event come from an authorized source? Do I know this source? Or is it just someone who is trying to inject an event into the system and making the system go crazy or make play around it? So your event data validation, if you're not doing event data validation, the problem you'll have is around malformed events, event injection, somebody putting an event that is not qualified, but your system is still running through its flow. So anytime there is an event, you need to validate that event. Second is access control. We need to validate who can create an event. Once that event has happened, what that event can do, what can you do, what can happen? You need to give that least privilege access to your serverless functions, your resources. So those are only doing for the certain job, and once that job is done, that they are going idle. That access control, you need to control them. Protect the data. Just going back to the earlier slide where I said, it's your responsibility for your own data. Your responsibilities around client-side encryption. So encrypt the data. Use the encryption. There are opportunities there. People should encrypt their data. And you might find it a bit funny, but it's still kind of not understood by a lot of people. They don't think about this. Credentials. You need to look at how we are making these calls. Who is the user? How the credentials are being used? If you're making an API call, how are you protecting your APIs? How are you using your API keys? Are you using auth credentials for that? Use key vaults, use secret managers to manage those credentials. Don't hard code credentials. It's a very simple thing to do. It's one of those things that you could avoid your problems. Don't hard code credentials. That's just a bad practice. Enable auto rotation. Every fixed period of time, enable auto rotate your credentials. Code scanning and third-party library scanning. We talked about the traditional model of having those physical servers, we started talking about, we are moving away from them. We are slowly moving away from them. So code scanning becomes has an important part. How you manage your pipeline, how are you securing your pipeline. If you're using any third-party libraries, are you scanning them? It's very easy to, pick up someone's code, pick up someone's idea from GitHub, copy paste that code and do it. But a lot of times what we actually miss out is someone's code is written being in a different context. They know the context. You're picking up the code. We are executing the code, but without the scanning is if the code is good enough for your own thing. Does the code have any vulnerabilities? The libraries you're picking up, do they have any vulnerabilities? Oh, sorry. The last thing, monitoring. We need to monitor our logs. We need to understand what runtime security is happening. Provide our security insights. How to have visibility around what is happening in your resources, what is happening in your functions, what your users are doing, what your APIs are doing. Anybody here have you ever been asked to provide any security reports? Yeah, we all love those graphs and we all love the trains, isn't it? But jokes apart, the point is that we have to monitor the environment. The visibility of your environment is quite critical. And I'll tell you a simple thing. The whole concept of old static environment is changing. When you start looking at serverless, your concept of static environment, because back in the days, defense in depth, we knew we have a server, we hardened the OS, we got our antivirus protection, we got user hardening, X, Y, Z. But because now we are looking in a very dynamic environment, some of those concepts need to be taken off. They need to be rethought about how we're going to do it. And that's why it's very critical we look at the runtime security of application. So I'm just going to take you guys through a simple scenario. It's a subset of a system development cycle that has happened, what we had looked at and where number of things we had covered. It's a very small example. So we are looking at here a system, the subset of the system. The context around the system was we have our front end, which is hosted in AWS cloud. We are providing the end users a facility to upload their files. We are doing an SFTP. We are picking up data from those SFTP site, putting it in our staging bucket. The staging bucket decides, depending on what data is, where we are going. It decides the destination bucket that is going to go to. And once it reaches the destination bucket, the Amazon Event Bridge triggers next set of events, and we process the data into the DynamoDB backend database. So in a very simple one is the event validation. There are a number of places we do event validation. And these are just some of the subsets that are picked up. One is we are actually checking if it's an authenticated user who is actually putting the data. If the data is actually being uploaded at the front end. Once that is done, the client app is picking up the data, putting it into the staging bucket. The next set of functions do the basic checks around the extension, if we expect this. Is there a virus checks? Very simple, yes or no. If it's a virus, put it in the isolation bucket, don't worry about it. If the file the data we know, the file is clean, next set of actions kick in. They do copy file to the destination bucket, remove the file from the old staging bucket. Once it reaches the staging bucket, the destination bucket, sorry, the event bridge says, okay, I'll go and look at what destination bucket it is in, validate that event, and decide what next Lambda function to execute, and it will go and put the data in the DynamoDB. Access control, your validation of user who is uploading the file to the SFTP site. You've got client apps who are picking up the data and validating correct client apps is actually picking up the data. Put the data in the staging bucket. You lock your bucket on the certain application has access to it. As you go through, you put the data back into the destination bucket. Again, that destination bucket is access controlled as well. We don't want anyone else to have access to the data while the data is in transit. The critical parts go through, and then again, executing the Lambda function and putting that data in the DynamoDB database, the backend database. It's still access controlled. The whole database is access controlled. The function that is actually writing the data back into the backend database has its own control over it. Encryption, every storage, outside of doing encryption in transit, every storage is encrypted at rest as well. They got their own set of keys that have been assigned. It's all controlled with the IAM policies. Who's got access to the keys. So in a simple way, the summary of everything is, while the serverless environments offers the flexibility, we don't have to worry about our resource scaling up and down. Our job as a developer or user is just to execute the logic. Security is still a crucial part. We cannot go away from security. We still have to own that part of it. There are 6 key concepts that we still need to look at. One is authentication and authorization. You really need to implement your strong authentication mechanisms. Control access to the servers, control access to the serverless functions, control access to the resources they interact with. Secure configuration, secure pipeline. Make sure that all the serverless functions have correct roles assigned. That wherever the data is being written, be it in storage bucket or your backend database, make sure that is actually access controlled. Data encryption, implement encryption at rest and in transit to protect sensitive data. Event validation, it's still quite a critical part because it's all event driven. So you have to validate what the event is doing. Make sure it's free of the injection attacks or any malform requests. Logging and monitoring. Implement correct logging and monitoring tools. Sometimes you have to think about going into the phase of monitoring the application rather than just the standard environment. And the last thing is, third-party dependencies and code scanning. You update your libraries. It's a lot of times you'll see when you run through the code scanning tools, you do static code analysis, you do dynamic code analysis. You'll see a lot of libraries that are being used are not updated correctly. They still have their own issues that they are carried on. So that's pretty much it. Thank you. And any questions? Sorry. Austin, I think somebody has a question.
One question ready. Awesome.
Thank you so much for the wonderful presentation. I have a question, do you have any recommendation of tools for the code scanning or external library dependencies?
I have used tools. I'm kind of trying to refrain from particularly, recommending one particular tool or anything like that. But you have to think about your own situations. Um, there are tools like Sona Cloud or Code Scan. You have, and I think there's Sneak as well. I haven't used Sneak. You need to think about that. If you're looking at dynamic testing, you can do a lot of fun stuff with likes of Zap and Burp suites and do it. But more importantly, the tools is just one part. You also need to think about, and sorry, it's a bit longer topic, but you also have to think about running the tool is one thing. The information you get out of the tool, how do you process that information? What do you do with it? Do you have any other mechanisms to fix the problem? And that's what we'll have to think. It's just, as I said, tools is one part of solution.
Any other questions?
In the serverless environment, like if you have a web application firewall, so there are multiple serverless functions. What's the best way to manage that one? So like either centralized manner or every function has its own instance of WAF?
It all depends on how your environment is, because your web application would manage your front end, but it's not going to manage your back end. Back end is still your responsibility. You do cloud security providers can do, or you can use your own WAF functions, but you still need to think about how everything chains in together. So your defense in depth concept is web application will cover, firewall would cover some part of it, but you still need to go back and do defense in depth for the whole serverless environment.
One more question. Anyone?
Again, thank you for the presentation. I'm curious, with using serverless infrastructure, to me it seems like it also introduces new challenges. For example, when I own the service, I'm allowed to run host IDS systems and antivirus system that will do in-memory analysis of the code that's being run by the application, which will help us to find out, for example, if a malicious code is being run just by the types of calls it initiates. But running it on someone else's service and not having the control over code runtime, what are the best practices of protecting that or building defense around this without just relying on AWS Lambda's rules, for example?
Yeah, I mean, I picked up AWS Lambda as one of the examples, right? You can still do it with Azure Functions. If you're using Google Cloud, you can still do it with Google Cloud Functions. But managing the backend of how the functions and security of the function, like in terms of actual infrastructure, is still CSP's responsibility. But we have to truly think about shifting left. In our traditional scenarios, our security is more reactive, I would call it. You're running host IDS, amazing, you're doing the job, but it's still kind of a reactive approach. Because what in effect you're doing is shifting left truly and managing your code better. In a way that the possibility of someone coming and doing a host-based IDS or even introducing a malware in your pipeline, you're reducing the possibility. I'm not saying it won't happen, but what I'm trying to say is if we put it shift left, we become more proactive. Some of these problems are caught even before they come to the production environment.
And that's all we have time for. Thank you very much, Mahesh.
Thank you. Thank you.